Okay, let's move on to 4.2. So you learned in calculus that the minima of a function occurs at the zero of its first derivative. Okay, so for number 2, we're going to use that fact to try to find the minimum of f. Okay? Alright, so let's bring up our text editor. And I have this find minimum function here. Okay, so above this function, I've put all the utility functions that we've seen so far in this class, and we can use all of them, or some of them, to implement this function. Alright, so find minimum. If you came to the review session, I used a lambda function to sort of encapsulate the idea of a derivative, and I think that confused a lot of people. So here instead, I'm going to use a named function. So def, I'm going to call it the derivative function, and it takes an argument f, right? And it has to return a function that is the derivative of the function f. And since it has to return a function, def, we should probably define some function, right? And it'll take a value x. We'll ignore the body for now. Derivative. Okay, so this is going to be the overall structure of our function. It is a derivative function that takes some function f and returns another function that is its derivative. And it is this derivative function that we need to find the zero of. Now notice how this is very different from approx derivative, because the approx derivative function takes two arguments, f and x, and it gives you the value of the slope at x for the function f. Okay, so actually in here what we need to call is we need to return approx derivative f and x. Okay, so essentially what I've done here is I've taken this approx derivative function and I've used this function here to wrap a second derivative of x function, and I've essentially first passed in the function f, and the value, the function that is returned will take an x, and it will pass this x in here, and we'll evaluate the derivative then. Okay? Alright, so now that we have a way to find the derivative function of a function f, then find minimum is just to find the zero of that derivative. So the answer is just to, find root. Find root is what we want. Okay? And what we want is the derivative function of the function f. Okay, so that's it. All we have to do is write a function that computes the derivative of a function, right? This is a higher order function, and find the zero of that derivative function. Okay, so now if I bring up my terminal and I import this file, I can say find minimum of lambda x. Let's do x minus 2 times x minus 2. Now the minimum of this function should be at 2, and we see that this value is very close to 2. Now, of course, the function doesn't find exactly 2 because in computer science we always have numerical precision issues, but I would say that 1.99995 is close enough to 2. Okay, now if you came to the review session, I gave a different solution that used the iter_improve function instead of directly using the find root function. And what I was doing there is essentially I was taking this function, I was taking this expression here, right? I was taking this expression here, and what I put here was the derivative function f. Okay, so you can also do this. Alright, and it's essentially the same thing, and on second thought, I think this is probably the easier way to understand the solution. But essentially, the solution that I gave in the review session just took the body of this find root and put it here. Okay?